All right, let's jump right in. Today, we're taking on one of the biggest, most powerful programming languages out there, C++. Now look, we're not going to make you an expert in the next few minutes. The idea here is to give you a kind of bird's eye view, a crash course, to help you wrap your head around its power, why it can be a bit complex, and why it's still an absolute giant in the software world. Okay, let's just tackle the elephant in the room right away. I mean, we've got all these slick modern languages like Python and JavaScript, so why on earth would you even bother learning a language that's older than a lot of people watching this? It's a totally fair question, and honestly, the answer is pretty cool. It's because C++ is this secret engine humming away behind the scenes of so much of our digital lives. When speed and performance are everything, absolutely non-negotiable, C++ is still the king. We're talking about the incredible graphics in AAA video games, the very operating systems and drivers that make our computers work, and yeah, even the super high-stakes world of competitive programming. When every single nanosecond counts, you reach for C++. So keeping all that in mind, let's start our little journey from the ground floor. We're going to look at the absolute basics of what a C++ program actually is. This right here is the classic hello world. It might look a little weird at first glance, but trust me, each piece has a really simple job. First, that #include IO streamline, that's just you telling the program, hey, go grab the toolbox for handling input and output. Easy enough. Next, int main. That's the starting pistol for every single C++ program. It's where all the action begins, no exceptions. Then you have cout, which is basically the command for print this to the screen. And finally, return 0 is just the program's way of politely saying, all good here, I ran without any problems. See? Not so scary when you break it down. Okay, so we've seen what a simple program looks like. Now let's peek inside and look at the actual building blocks. No matter how huge or complicated a program gets, it's all built from these fundamental little pieces. These are your raw materials. And here are those ingredients. At the end of the day, programming is really all about moving data around and changing it. In C++, that data comes in a few basic flavors. You've got int for your whole numbers, double for decimals, char for just one single letter or symbol, bool for a simple true or false, and string for text. Just about everything you'll ever build is some clever combination of these guys. So if those are the ingredients, how do you actually do anything with them? Well, you use operators. You've got your basic arithmetic for doing math, comparison operators to see if something is bigger than, smaller than, or equal to something else, and logical operators to chain together true/false ideas. Think of these as the verbs of the language. They're what get things done. All right, so everything we've talked about so far, you'll find similar ideas in lots of other languages. But now we're getting to the power-up. This is where we uncover the one thing that truly, fundamentally separates C++ from the rest of the pack. And this right here, this is the core philosophy. It's the whole ball game. While other languages have these automatic systems that manage memory for you kind of behind a curtain, C++ just hands you the keys to the car. It gives you direct, bare metal control over your computer's memory, and that is the secret sauce to its incredible speed. So how do you actually use that control? You use a special tool called a pointer. Now, this concept can trip people up, but the idea is actually really simple. A pointer doesn't hold a piece of data itself. Instead, it just holds the address of where that data is stored in memory. Here's a really easy way to picture it. Imagine a normal variable is a storage box. Inside that box is your value, let's say the number 10. Simple enough? A pointer, though, isn't another box. It's more like a little sticky note. And on that sticky note, you don't write 10, you write the address of the box that has the 10 in it. That one little difference is what unlocks a world of high-performance programming. Okay, I know what you might be thinking. Memory addresses, pointers, this all sounds really tedious and low-level. And you know what? It can be. But modern C++ isn't just about that stuff. Let's move up a level and look at the powerful high-level toolkits that let developers build massive, complex software without pulling their hair out. And the main idea here is something called a class. The best way to think of it is as a blueprint. You wouldn't build a house without a blueprint, right? A class is a blueprint for an object in your code. It lets you bundle together all the data that belongs together, like a person's name and age, along with all the functions that can do things with that data, all in one clean, reusable package. This is the heart and soul of what we call object-oriented programming. So if a class is like a custom blueprint you design yourself, then the standard template library, or STL, is like a massive warehouse of perfectly engineered, prefabricated parts. Honestly, this is probably the most important part of being a modern C++ programmer. It's this huge collection of components, broken down into three main categories: containers to hold your data, algorithms to process it, and iterators to link the two together. And here are just a couple of the greatest hits from that toolkit. For example, need a list of things that can grow or shrink whenever you want? Don't build it yourself, just use a vector. It's a smart array that handles all the memory management for you. It's amazing. Need to store things by a key, like a word and its definition in a dictionary? Use a map. It's incredibly fast. And then you have these super optimized algorithms like sort that you can use on your containers with just one line of code. The STL is what makes C++ developers so incredibly productive. Wow, okay, we have covered a lot of ground, from the absolute basics all the way up to high-level architecture. So, what does it really take to climb to the top of this mountain? What's the path to actually mastering C++? Let's break it down. First thing, and I cannot possibly stress this enough, master the STL. Seriously, knowing this library like the back of your hand is the single biggest step you can take toward becoming a great C++ developer. Before you ever think about writing your own custom tool, check the STL. Odds are a better, faster version is already there waiting for you. Number 2, you have to truly master pointers and references. There's just no getting around it. If you want to harness the real power of C++, you have to get comfortable with thinking in terms of memory. It's not just about learning the syntax, it's about understanding the performance impact of every single choice you make. For any serious C++ work, this is a must. Third, you've got to master object-oriented programming and templates. See, C++ isn't just for writing small, fast little programs, it's for building massive, complex systems. And to do that, you have to think like an architect. That means really understanding how to design good classes and how to use the template system that the STL itself is built on. And finally, number 4, master time complexity and memory management. Let's not forget why we're here in the first place, right? We use C++ for its performance, so it's not enough to write code that just works. You have to know how to write code that is brutally, ruthlessly efficient, both in terms of how fast it runs and how much memory it uses. Which brings us to our final thought for the day. C++ gives you ultimate control, ultimate performance. It trusts you, the developer, to work directly with the machine in a way few other languages do. But with all that incredible power comes a whole lot of responsibility. So the real question isn't just, can you learn C++? It's, are you ready for that responsibility? Thanks for joining me.